Good morning, everyone, and welcome to today's webinar on antimicrobial resistance. I also extend this warm welcome on behalf of the Director General Human Resources, Ministry of the Public Service, and the Director of the Learning and Development Directorate, the Ministry of Agriculture, the Ministry of Agriculture, Food and Nutritional Security, and the University of the West Indies, with whom the Ministry of Public Service has collaborated to share this very important message and information with you. This session is being recorded and will be uploaded to the Learning and Development Directorate's YouTube channel, where you can go at a later date and review this very important information, which will be shared with you today. I am Jeanette King, and I am your moderator for this session. I am Human Resource Officer at the Learning and Development Directorate. Assisting me in this session this morning is my producer, Ms. Sheila Grisette, Senior Human Resource Officer at the Learning and Development Directorate. You can say hello, Sheila.
Good morning, everyone. Welcome.
Thank you. This session is being recorded, as I said before, and will be uploaded to our Learning and Development Directorate's YouTube channel. So how are we going to be interacting in this virtual space during this session? Your cameras remain off. Our presenters will turn theirs on briefly to greet you. Your audio should remain closed. You may use the chat to post a very important message. There will be a questions and answer segment at the end of the presentation. However, even prior to the Q&A, you may go ahead and drop your questions or comments in the Q&A box. So as the presentation proceeds and as questions pop up in your mind, please type them in the Q&A, or you can jot them down. During the Q&A segment, our presenters will review your questions and share the responses. This whole thing about antimicrobial resistance, or AMR, it is no longer a distant issue. It is happening now. It's affecting healthcare, agriculture, and economies worldwide, including right here in our region, in Barbados. With this rising resistance to antibiotics and other treatments, we face the risk of once treatable infections being life-threatening again. Today, we will explore the key drivers of AMR, its impact on public health and industries, and most importantly, what we can do to mitigate its spread. This is a conversation that calls for urgent attention, action, innovation, and collaboration at every level. So colleagues, we have with us this morning to have this very vital conversation with you, Dr. Marquita Gittens St and Mr. David Elcock. Dr. Gittens will not be able to open her camera. She has an issue there. But anyway, I will continue to give you a little bit information about Dr. Gittens St. She is a senior lecturer in microbiology in the Faculty of Medical Sciences at the University of the West Indies, KPhil, former director of the Leptospira Laboratory. She specializes in the molecular diagnostics of infectious diseases, particularly arboviruses and leptospirosis, and has an avid interest in the investigation or epidemiology of multi-drug resistant pathogens, genotypic and phenotypic characteristics. She is a member of CARBIVET Technical Working Group, American Society of Microbiology, Caribbean Association of Clinical Microbiologists, CARBIVET-NET Technical Working Group, the quadruped technical working group on antimicrobial resistance or use and integrated surveillance, and the University of the West Indies representative of the AMR multitask Stakeholder Partnership Platform. Mr. David Elcock is a Senior Agriculture Officer with the Ministry of Agriculture, Food and Nutritional Security. Mr. Elcock earned his Master's of Science degree in Veterinary Microbiology from the Royal Veterinary College, University of London. He has an associate degree in Medical Laboratory Technology from the Barbados Community College and a postgraduate diploma in Public Sector Management from the University of the West Indies. Mr. Elcock managed the Veterinary Services Laboratory in the Ministry of Agriculture for over 18 years and is the ex-chair of the Regional CariVet Laboratory Working Group. Currently, he is the ministry's focal point on antimicrobial resistance and a member of the quadripartite, which includes the World Health Organization, the World Organization for Animal Health, the United Nations Environment Program, and the Food and Agriculture Organization. Multi-taskholder partnership platform. This is the multi-shareholder stakeholder partnership platform. A warm welcome, Dr. Gittens St, Mr. Elcock.
Hi, good morning.
Good morning.
So as we start the session, Dr. Gittens St will take us through the first part of the conversation, and Mr. Elcock will take over for the second part. Welcome again, colleagues, and over to you, Dr. St. Hilaire.
Good morning, everyone. Thank you for the invitation to give this presentation. So we'll be talking today about antimicrobial resistance, why you should be concerned. And with me, as mentioned before, is my colleague, Mr. David Elcock from the Ministry of Agriculture, Food and Nutritional Security. So we'll start you off very early with a quick poll to find out what you know. So we will display the poll on the screen, and we'll give you about a minute or so to select responses. So you can go ahead as soon as the poll is placed on the screen, just click your responses, and then we will go from there. Okay, so I can see that regarding question 1, everybody's heard of COVID, and we should all have heard of COVID because we did pass through that pandemic in 2020. It would have started at the end of 2019, but 2020 and beyond. And in terms of AMR, I see about 74% of persons have heard about it, and there are some persons who've not heard about AMR. So we will proceed on with our conversation. So regarding today's talk, this is how we will go about it. And I will piggyback on that poll in a minute. So we are looking at antimicrobial resistance, the what, the why, the hows of it. We'll also point out some important statistics. We'll look at the economic case, in terms of money. We'll look at the linkages in terms of humans, animals, the agri-food systems, and we also look at the environment. And finally, we'll look at what we can do about it. So you would have heard, as mentioned, or you would have, most of you would have, all of you actually would have said you've heard of COVID-19, which was a global pandemic that hit us about 5 years ago. But how many of you know that AMR, or antimicrobial resistance, is a pandemic as well? It's just not as monstrous or in your face in terms of COVID-19, but it is a pandemic as well. And it has been in existence even before COVID-19 raised its head. And so by 2030, it's believed that they would have 5.2 million deaths associated with antimicrobial resistance. And it's believed that it's going to cost us not only deaths, but also in terms of money. There will also be some effect on the GDP of countries as it relates to treating antimicrobial resistance, mitigating against antimicrobial resistance. So what are antimicrobials? So I'm sure you've heard of antibiotics. So antibiotics are drugs that will kill or inactivate bacteria. And I'm sure one of the primary drugs you probably would have heard about before was a drug like penicillin. But we also have drugs against other microbes. So one of the microbes would be bacteria. Another microbe would be viruses. COVID-19 was a virus, and we have drugs that can either kill or inactivate organisms or viruses as well. We have drugs against fungi. So we have antifungals that are able to kill or inactivate fungi. We have antiparasitics, those that are against parasites, like malaria, for example, that can kill and inactivate parasites. We have antiseptics. These are things that you have seen, probably even have in your household, that can kill or inactivate microbes on the skin. So when you go to get your bloods drawn or so, you would find that persons would probably prepare your skin by wiping it with an alcohol swab that's able to remove organisms from the surface of your skin, but also to kill and inactivate them or inactivate them. And then we have disinfectants, things like Clorox, that can also kill or inactivate microbes on intact surfaces. So then we have some biocides, fungicides, insecticides, herbicides. All of these are biocides, which are pesticides that we have used or may have used at some point in time. And collectively, these are all called antimicrobials. And why? There are drugs used or chemicals used against microbes or microorganisms. So what is AMR and who does it affect? So antimicrobial resistance occurs when those same microbes, the bacteria, the viruses, the fungi, and the parasites change over time, so that the drugs that you could have used before to treat them are no longer working. So before you could have used penicillin to treat a lot of infections. Now penicillin, you can't use penicillin as much as before to treat some of these infections. Thus, it makes it harder to treat the infections, and it also increases the risk of spreading disease, because if you can't treat the infection, it means you can spread it to others, persons can become more ill, and certainly it will lead to more deaths. And this occurs in humans, it occurs in animals, and it can occur in our crops and our agri-food systems, and it can also be part of our environment as well. So how does this whole interaction work? We mentioned humans, we mentioned animals, we mentioned plants and crops, and we mentioned the environment. So when we take antibiotics down here, and we use them or misuse them, abuse them, as humans, the bacteria can develop resistance. So we can acquire these organisms from a number of places, hospitals, communities, families. As we travel, we can acquire these organisms, these bacteria in particular, because we're talking about antibiotics in this particular instance. These bacteria can acquire resistance, and then we can spread them. So firstly, we have humans. We have acquired these resistant bacteria, and then on defecation, they can get into the contact into water. So they can, via sewage, they can contaminate the water, get into the environment. And vice versa. If there are any resistant bacteria in the environment, we can acquire those through food or even drinking contaminated water. Once it gets into the environment, we have animals, there are wildlife and so forth, even pets that can go and eat the plants or crops that might have been contaminated, waters and so forth that might have been contaminated, and they now become resistant. Simultaneously, these animals would same thing, defecate, use manure, so spread on crops, spread in the environment, spread in water, and the environment can also become contaminated that way. Humans come into contact with these animals, and because of contact, not only with our pets and so forth, but also through food, then we can also get these resistant bacteria. So basically, this whole quadrant is known as One Health. They're all interlinked. There's all interconnectedness between these sectors, the humans, the animals, the environments, and the crops and the plants that you see here. And once you start to use, misuse, and abuse antibiotics, particularly misuse and abuse of antibiotics, then this can lead to the transmission or the antimicrobial resistance pathway that you see here. So what causes this? So presently, the inappropriate use of antibiotics in humans and animals has led to development and spread of antimicrobial resistance. Firstly, when we overuse the antibiotics, we underuse the antibiotics. So overuse, you use them for when they're not indicated. Underusing them, you use them, use all of them. So you're underusing the antibiotics. You're not finishing the treatment course. You're incorrectly disposing of antibiotics. So you're putting them in places where you shouldn't. Down the toilet, for example, down the sink, in the garbage. We're incorrectly disposing antibiotics so they can get into the environment. You use broad spectrum antibiotics when narrow spectrum antibiotics will suffice. And there are some antibiotics that can cover a wide range of organisms, a wide gamut of organisms, and there are some that can only cover a limited amount. So sometimes you use a broad spectrum, one that covers everything, when really you just want one that is limited, has a limited spectrum. The blanket use of antibiotics in an untargeted manner, we use them basically, as I would say, willy-nilly. We use them when they're not necessarily indicated. The treatment of bacteria that are not susceptible to a particular antibiotic. The treatment of diseases caused by viruses or other microbes not susceptible to antibiotics, and it goes vice versa. When you're given, for example, maybe an antifungal to treat a viral infection, they're not going to work. So it leads to resistance developing as well. And then one of the things that we never really always put together when we're thinking of antimicrobial resistance is clean water. So when you don't have clean water, sanitation, and hygiene, or what we call the WASH measures, and we don't have adequate infection prevention and control measures, then it leads to the spread of microbes. And this can then exacerbate antimicrobial resistance. So we talk about the misuse, the abuse, all of these, and the overuse can result in antimicrobial resistance. So if we start down here, and we've taken some antibiotics. So the antibiotics we see here are in the capsules, and then we have some bacteria, some blue ones, and some green ones. So we've taken the drugs, and the drugs are supposed to get rid of the bacteria. If we follow the arrow, we will see that the green ones remain. So the antibiotic basically has removed the blue ones. So what has happened there? It means that those green organisms are actually resistant to the antibiotic. They're able to survive even if the antibiotic has been given. So it kills a subset that were susceptible to it, but there are some that have survived beyond that. And then these resistant ones continue to multiply, and they pass on their progeny to their generations, the subsequent generations, so that now when you are now given that same drug that you gave before to the person to treat the similar infection, what happens? The drug no longer works because those bacteria were replicating even in the presence of the drug, and so being able to pass on to their progeny. And so when you get the drug again, it doesn't work. And this happens a lot when you misuse, when you abuse, or you overuse antibiotics. And let's see how this happens. So persons, you're exposed to the drug. That's the first thing that happens. You're exposed. So the organism has now become exposed to the drug. You're taking the drug. But what can happen after that is that what happens as a normal, normal living, normal life, is that things evolve, things adapt. So you have taken the drug, right? And the organism has sometimes on its own can spontaneously mutate. So it can change the way in which it can react to the drug. And when it changes that way in which it reacts to the drug, then it's now become resistant to the drug. So what you can have are genetic mutations that can lead to this resistance developing. So we will see that you might have had one organism that was susceptible. It either acquired that resistance or that mutation from another organism, or it could have spontaneously mutated and spread that resistance now onto its progeny, onto future generations. And so then it can transfer the DNA to others. So within its own family of bacteria, or it can look at other strains, other genus, other species of bacteria. It can transfer those resistance genes to other organisms. And so if we look here, we see this bacteria initially had no resistance, but then it subsequently acquired more resistance genes, and it required more resistance genes, and this can spread, as I said, between different organisms. Now let's look at some important statistics. In 2019, it was estimated that 1.27 million deaths were directly associated with antimicrobial resistance, and nearly 5 million people in 2019 would have died from multi-drug resistant or resistant infections, particularly, like pneumonias in the lower respiratory tract, in the bloodstream, so sepsis, and even intra-abdominal infections. And they believe that and it's expected rather, that between 2025, this year, and 2020 and 2050, so in 25 years, that they will have 29 million deaths due to antimicrobial resistance. And it's also estimated that that will have another figure associated with it as well. It's also believed, or seen rather, that 1/5 of persons who die from antimicrobial resistance will be children under the age of 5 from previously treatable infections. And this also similarly affects the elderly, because the elderly tend to have more underlying comorbid conditions, where we have things like diabetes and hypertension, which kind of places them at risk for getting infections and then developing multi-drug resistant infections as well. So we have it at the extremes. Those that are very young, and then those that are older, they are at increased risk of multi-drug resistant infections. And furthermore, it is estimated that between 30 to 50% of all antibiotics are incorrectly prescribed in human health. But this impact is not only affects lives, but it also extends beyond that into our finances. It's believed by 2050 that a US 1.7 trillion annual reduction could occur, or 0.88% of GDP could occur, if we did things to mitigate against antimicrobial resistance. But it costs right now $412 billion per year additionally to treat AMR. And it also affects our productivity as well, because certainly persons can become ill, are ill, and they will require advanced treatment, because usually once you develop antimicrobial resistance, it means, as I said, the drugs that would have been working before can no longer work. And then not only that, you might have to now get more expensive drugs. So it adds healthcare costs. And then the person might have to go into an intensive care unit. So that adds more costs now. So you have costs in terms of that. And then these persons obviously cannot work. So there's loss of workforce productivity. And then even if they're discharged, sometimes you might have to get persons now to care for them. So further now loss of productivity. And that's estimated at US $443 billion per year. It's also projected that there would be reduced revenue from tourism and hospitality-based industries, particularly in poor countries. These tend to be more vulnerable than countries with more robust health systems and with higher GDPs. These ones tend to be more resilient. With poor countries whose reliance is on tourism and hospitality, certainly if persons go to your country, you know, if you have a tourist visit in your country, they develop a multi-drug resistant or a infection, antimicrobial resistant infection, what's going to happen? They might not come back. So the word might spread, and hence what can happen is then you have a reduction in your revenue. And then also persons who might be traveling, similar thing, from the island out to somewhere else, they might even bring infections back. And then, you know, the healthcare costs usually associated with treating antimicrobial resistant infections is certainly higher than if you had to treat infections that were generally very well susceptible to those drugs. So now, you know, in countries which are poor and so forth, low income countries and low to middle income countries, these tend to fare worse, particularly in this area, not only in terms of productivity, of hospitality and tourism, but generally in terms of antimicrobial resistance. They tend to have the highest burden of antimicrobial resistance. Now let's bring it a bit home to antimicrobial resistance in Barbados. In 2019, there were 79 deaths attributable to AMR, so directly associated with AMR, and 312 were associated to AMR. And when we look at this chart here, we see that cardiovascular diseases is the number one, followed by cancers and neoplasms, followed by diabetes and kidney disease. And then look what we have next: antimicrobial resistance. And these were primarily as associated with respiratory tract infections. So some pneumonia, possibly, most likely tuberculosis, which is also affects the lungs, neurological disorders, and so forth, skin diseases. These have been what the deaths from AMR were associated with. So we can see that yes, it's out there globally, but locally, we also are being affected by it as well. So now we have our second poll, and I want you to take a minute or so to answer these three questions, and then we'll talk about it. So you can load the poll now, and you will just, as before, you will click the screen, and you will click your option on the screen.
Okay. Dr. St. Hilaire, Jeff having a little issue here with the launch.
Okay.
So just a moment, please.
Okay. So we would hopefully get that poll to you in a little bit, but in the meantime, you can think about your responses to those questions. And the questions are, have you ever taken antibiotics for a cold? Have you ever taken antibiotics without a prescription? Have you ever stopped taking the antibiotics when you felt better? So you can think about those.
Okay.
So we're ready to go with the poll.
Okay. Apparently there's some technical issue. It's not being launched. So what we are going to ask the participants to do is to please share their responses in the chat, as we're going to start with question 1. Have you ever taken antibiotics for a cold? So you could put Y for yes in the chat, N for no, or M for maybe.
Okay, so we can see that some persons have taken antibiotics for a cold, and some persons said no, they've never taken antibiotics. Someone says no to all, so never taken any antibiotics for a cold. Okay.
Okay, so thank you, participants. Our next question is, have you ever taken antibiotics without a prescription? Have you ever taken antibiotics without a question? And again, Y for yes, and for no, and M for maybe.
Okay, so we are seeing some yeses, some no's, some maybes. So we're seeing some persons have taken antibiotics without a prescription, and some persons have not. And then a few maybes. So once we've answered all the questions, then I'm going to quickly talk about them, and then we would progress.
Okay, so with our last question, did you stop taking the antibiotics after feeling better? Did you stop taking the antibiotics after feeling better?
Okay, so we see some yeses, some no's, once again, some maybes. In response to this question, question 3, have you ever stopped taking antibiotics when you felt better? And we know a little bit from what we would have mentioned before and now going forward that it is not appropriate to take, and thank you for your honest responses, everyone. We should not take antibiotics for a cold, because a cold is caused by a virus, and we really should be only taking antivirals for anything that is viral. But colds, we don't have any specific antiviral agents to cover colds. Have you ever taken an antibiotic without a prescription? Antibiotics are generally prescribed. Of course, there's some over-the-counter topical antibiotics, you know, that would use like your polymyxin, neosporins, and stuff like that, which are over the counter. But generally, if you have an infection, a major infection or so forth, those antibiotics should always be prescribed by a physician. And as I said, by a physician, no one else. You shouldn't even take it from family members or friends. You should go to the physician, determine firstly if it's an infection, and then be administered or be prescribed the antibiotics or whatever other agent is required as necessary. And then, have you ever stopped taking the antibiotics when you felt better? You shouldn't, because it will contribute to antimicrobial resistance. It's always important to ensure that you take your complete course of antibiotics. And in terms of, so thank you very much again. In terms of antimicrobial resistance and human health, antimicrobial resistance can actually undermine the gains made over the last 100 years of antibiotic therapy, making once easy to treat infections now becoming untreatable. It's, you know, the first antibiotic was really discovered in 1928. It's not even 100 years yet, really, since we've had the first antibiotic, and we're seeing antimicrobial resistance. And the number of deaths associated with antimicrobial resistance has surpassed the combined deaths of HIV, malaria, and TB. And so the World Health Organization has declared that antimicrobial resistance is one of the global top 10 priorities facing human health, the top 10 public health threat facing humanity. And therefore, we need to be concerned about that. So now I'm going to hand over to Mr. Elcock, who will take you through this part of the presentation.
Hello, hi, good morning. Can you hear me?
Yes, we can.
Okay, great. I'm not seeing my camera. Start again.
You're on. It was on just now.
Okay, great. So, my name is David Elcock. I'm from the Ministry of Agriculture, Food, and Nutritional Security, and thank you, Dr. Gittens St. Hilaire. So, you know, initially you may ask yourself, well, what does the Ministry of Agriculture have to do with AMR? What is their role in antimicrobial resistance? So you may or may not be surprised to know that a large percentage of antibiotics which are used and produced are used in animals. And we can see here about 80% of antibiotics that are produced are used in animals. That's a whopping number of antibiotics that are being used in animals. And I will say that these antibiotics are not only used in animals, these antibiotics are also used. These are the same very antibiotics that are used in people. And if in the agricultural industry, they're mostly used in a growth promotion, a prophylactic, or a metaphylactic way. And let me just briefly explain what that means. So oftentimes, antimicrobials or antibiotics are used for growth promotion in livestock. And when it comes to animals, we can talk about livestock. If you hear me say livestock, I mean animals that we eat, the cattle, the sheep, chickens, and if I say companion animals, I mean the ones that we don't necessarily eat, the one that provide companionship, like dogs and cats. So growth promotion is a practice that has been outlawed in some countries, but not in all. And it is the addition of antibiotics to feed merely to enhance the growth of the animal. And prophylaxis, on the other hand, is the use of antimicrobials or antibiotics for in animals when there's no evidence of disease. And metaphylaxis is used in animals, also in feed sometimes when there is evidence of disease or subclinical infection. I hope you understand the difference. So farmers use antibiotics in animals. And oftentimes they use antibiotics in plants as well. We are using a lot of medically important antibiotics in the treatment of plants. For instance, oranges and in citrus, we use antibiotics in plants. We use antibiotics in the production of rice, and oftentimes, again, medically important antibiotics and insecticides and fungicides in some countries. And in aquaculture, again, aquaculture is the rearing of fish or marine species, either inshore or out to shore. We're using up to 33% up to 2030. We're using at least 33%. It's increased by 33% in animals in aquaculture. In addition, AMR and agri-food system. Next slide, please. So it's further estimated that the annual livestock production losses due to AMR could jeopardize food security, therefore pushing another 2 billion people into food insecurity by 2050. Already we are facing a very perplexing problem, how we're going to produce enough food in the next 25 years to feed an ever-increasing population. We have about 8 billion people. Now we're going to have at least 10 billion people by 2050. And we are already stretched in our capacity to produce food, and we need to produce a lot more. And here we have at least 2 billion people, being forced into food insecurity by 2050. Next. So AMR and the environment, and also you may ask what happens in the environment, and the environment is often not responsible for AMR and pollution, but it is a very good vehicle and a reflection of what goes on in the animal, human industry and plant industry. Because all of the antibiotic that is used in these sectors, it needs to go someplace. And what happens, it goes into our environment. And up to 75% of antibiotics is used in agriculture and may be lost into the surrounding environment. We have a lot of antibiotic residues, or what we'll call in the environment as contamination, coming from municipal waste, from waste from humans and from hospital and from pharmaceutical industries and industry on the whole. And you have a lot of multi-drug resistant bacteria that are prevalent that get into the water and get into the soil. So the environment is being contaminated and polluted by antimicrobial resistant organisms. And that plays into the triple planetary crisis. You may have heard our Prime Minister is always talking about the triple planetary crisis. That pollution from antibiotic use gets into the environment. Could click, please. Click all the way. Right, so that pollution gets into the environment, and it comes from all of these different sources. And the most threatening ones are the ones that come from treated and untreated human waste, right? And residual waste from pharmaceutical companies and manufacturing. And antimicrobials in the soil. Antimicrobials in the soil have an ecotoxicological effect that can disturb the soil and the plant health. And that leads to biodiversity loss. And a lot of the organisms that are living in the soil and that the soil needs for fertility are lost due to the toxic effect of antimicrobials in the soil. And of course, climate change, they say it was a study that was done, a 1 degree Celsius rise in temperature can lead to significant effects on animals and on disease and also on marine life. 1 degree Celsius rise can lead in an elucidation of disease in plants and in aquaculture and fish marine life. Next slide. And we come on to the Sustainable Development Goals. And the Sustainable Development Goals are internationally designed objectives aimed at ensuring a habitable world, eradicating poverty, enhancing economic growth, and ensuring that all of humanity lives in harmony. And countries internationally, these countries use these Sustainable Development Goals as development indices. These are the things that we need to have working in our society and our communities in order for countries to develop, in order for there to be enhanced economic growth. Simple things like no poverty, which is goal number 1. We need to reduce poverty. The Sustainable Development Goals looks at halving the percentage of poverty in communities, and also in agriculture to reduce to end hunger and in health, good health and well-being. And all of these goals are threatened by antimicrobial resistance in one way or the other. So when we look at crop production and livestock and agriculture, a lot of our protein that we eat comes from agriculture. If we can't produce protein due to antimicrobial resistance, we can't get rid of hunger. We can't have good health and well-being if we're not eating. If we're hungry, we can't be healthy. We can't have goal 6, clean water and a clean marine environment, if we have antimicrobial resistance contaminating corals and contaminating marine life and sediment. And of course, we goal number 5 is gender equality. A lot of farmers and farming is done by women. The majority of the world's farmers are women. And again, these are the first people, especially in the global south, the persons who will be pushed into poverty and hunger, first of all, because AMR will affect the global south, countries in the global south in a very disproportionate way. So it requires an urgent multi-sectoral action in order to achieve these Sustainable Development Goals, especially ones focused on health, well-being, poverty reduction, and food security. So, and the next slide, AMR, we're here to make a case for why we should be concerned about antimicrobial resistance. The rapid global spread of these superbugs that cause infections that are either slightly treatable, not nearly untreatable, or not treatable at all with the existing antibiotics. And the clinical pipeline, we call it the clinical pipelines of new antimicrobials, is almost dry. You may ask, well, why don't we develop new drugs? But the fact of the matter is that there's a declining proposition for big pharma to produce new drugs, since these drugs in a few years' time there's resistant buildups to these drugs. The last drug that was produced was in late 2024. And I'm sure given in a few years time, there will be resistance built up to that drug as well. And if you think about when a company produces a product, so we're asking persons to be judicious about their use of antimicrobials, but we're also asking companies to produce new antimicrobials. So if you think about how like a fire extinguisher is used, if you purchase a fire extinguisher, the company makes money when you purchase another one. But if you take that fire extinguisher, you put it in your house and you wait for a fire, maybe a year goes by, 2 years go by, the company makes no money because you still have a working fire extinguisher. And drugs are very much that way. We want them to be used, but only in certain situations. But the company obviously wants to make and sell drugs. So the clinical pipeline is right now what they say it is dry. And it's because these antibiotics are becoming increasingly ineffective as drug resistance spreads globally, leading to more and more untreatable infections and death. The cost of AMR to national economies is staggering. We are looking at by 2050 a drop in a global GDP of up to $43 trillion. So the cost to national economies is staggering. And of course, as I just mentioned, in the global south, we will always be affected disproportionately by global loss of GDP, longer hospital stays, more expensive and treatment and intensive care, and medical procedures such as surgery. And once upon a time, these conditions that we easily treated with antibiotics, hip replacements and cancer chemotherapy, these things will become even more and more risky in the future. Taking us back to a World War II era where we only had penicillin, the single drug that could be used, and then we had to use other things outside the antibiotics because there really were not that many antibiotics that could be used. So AMR threatens to push the world back almost 100 years in progress. So what are the mitigation strategies? What can we do, to combat AMR? So what we're here today trying to do is to improve awareness and understanding, because what we can do as persons, there is something we can do. We can, if I jump to the last point, there's self-regulation. You know, self-regulation, I believe, is the best regulation. We don't always need government to step in with legislation and regulation and rules. Self-regulation is the most important. If you are aware of what you're doing, if you're underdosing yourself, you're sharing antibiotics in your household, you're going to your best friend and getting antibiotics instead of going to the doctor. If we are aware of what these things are doing to our bodies, to our families, to our communities, then we have to regulate how we use antibiotics. So that's the best type of regulation in my mind. We need to reduce the incidence of infection. Again, wash your hands properly, optimize the use. So we know when we go to the doctor, we need to take a certain type of drug as opposed to an antiviral if it's a cold. A lot of you would have answered yes, you take antibiotics for a cold. You know, that is not necessarily the thing to do. So we need to optimize the use of the drugs that we have that are still working. And when we look at a mitigation strategy like antimicrobial stewardship, for instance, the one highlighted in red, that very much focuses on the judicious use of antibiotics, not only in human use, but also in animals and in plants and the agri-food system. And of course, when we talk about livestock, we can't talk without mentioning food, because the livestock we use for our food. So what is not getting us through the doctor or actually through when you don't use antibiotics in the right way, is getting through the food, because obviously when you use antibiotics in food, then you also take that food in by using animal products as well. So what can we do as opposed to what I can do? What can we do? Because we can do certain things as individuals, but collectively we need to do a lot of things. First of all, we need to use antibiotics a lot wisely. We need to be very careful about how we use antibiotics, including the over-the-counter antibiotics. You know, it's over-the-counter, yes, but it's not necessarily the best way to always run for over-the-counter antibiotics. But in farming and agriculture, we as farmers and agriculturalists, we need to also consider the use of antimicrobials and antibiotics in animals. There's a drying off period after you've used an antibiotic, say for instance, in cattle. Give the antibiotic time to go through the animal system so that when you use the milk, you don't get contaminated with antimicrobial residues. So, and we need to wash our hands as farmers as well. We need to wash properly as farmers. You know, in agriculture, we're obviously interested in animals. You know, you need to wash if you're, for instance, milking the animals, wash your hands properly so that you don't contaminate the animal as you're milking it. You know, get vaccinated. Of course, you know, this slide really speaks to humans, but of course, all of this is also relevant to animals. Instead of using antimicrobials and antibiotics in animals, we need to use a lot more vaccination. Animals do get vaccinated for a lot of the disease as well, and don't spread disease, of course. Raise awareness, teach others, teach your children, your colleagues, and of course, what we are doing in the national task force is look for a champion. We all become champions of judicious use of antimicrobials and antibiotics. So I think this one, Dr. Gittens will take this one. Dr. Gittens? St. Hilaire, sorry.
Yes, please. So I'll go with. So there's been currently there is a questionnaire on antimicrobial resistance in the public, a knowledge, attitudes, and practices questionnaire or survey currently being distributed. And I just want to share a few of the preliminary results with you, which kind of tacks back on to some of the questions we had asked you originally in the poll. So one of the first questions we asked was, have you ever taken antibiotics for a cold? So similarly, we had asked, what was the reason for taking your last antibiotic? And we just focus on this first one, where it says cold. So we see 8.33% of persons said that they took antibiotics for cold, which may be similar to the percentage of persons that might have here who said, yes, I took antibiotics for a cold. And so now going forward, we can be sure to say, yeah, well, that's something I did in the past, but knowing that now it can contribute to antimicrobial resistance is not something that I will continue in the future. And then have you heard of any of the following terms? So this was one of the first questions we asked, and we can see if we looked at antimicrobial resistance, AMR in itself, just a small proportion of persons would have heard, about a third or thereabouts, so 35%. And when we look at antimicrobial resistance as it's being spelled out a little bit more, about 60% or thereabouts. And then in terms of antibiotic resistance, yes, everybody's heard about antibiotic resistance. But when we look, we can also see a small subset who've never heard about antimicrobial resistance. And so today, this is one of the objectives for this particular proposal, for this particular webinar. How do you mostly take antibiotics? We see that most persons have, said that they go by a physician's prescription, but then we see some self-medicate, some take when it's suggested by friends, by pharmacists, or previous prescription, leftover prescription. Really and truly, we want this to be 100% where the physicians, where you take antibiotics that are prescribed by physicians. And then the final one, after taking some of the antibiotics and you feel better, do you still complete the full course of treatment? About 19% said no. So we certainly want this to be over here. So we want the no's now to be yeses. You want to make sure that you complete the full course because of having subtherapeutic levels of the drug, then it forces the bacteria to become resistant. It's trying to survive. So because of having small amounts in your system, taking subtherapeutic levels is going to cause the bacteria to want to say, well, look, why you got this here against me? Why you going to try to fight and want to survive? So hence and therefore, it's going to change, mutate, do what it needs to do in order to be able to survive. So we want you to take the full course because the full course has been known to eradicate the organism. So now I'm going to turn you back over again to Mr. Elcock.
So thanks again, Dr. Gittens St. Hilaire. So I hope that we've made a case in your minds for the reasons why antimicrobial resistance is a global concern, and it's also should also be a concern here in our country. We've given you the estimates, we've given you the economics, we've given you how it's done and what we can do to mitigate against it. Even if we look at the fact that our GDP is going to be tarnished, our tourism arrivals, the revenue from tourism may drop because of AMR, and also to our health. The health of our people is in question. And in this country, in the global South countries, we don't necessarily have access to every antimicrobial. And even though antimicrobials, like the one I mentioned in 2024, has been developed, we may not see it here on our shores for many, many years because we know global South will always be second in having a lot of these drugs in our formularies. So I hope that we've made the case, and I hope that by now you would have thought about it, given a lot of thought and things that we do or we don't do, and that I've made a case for you to be very concerned. So the questions left is, are you concerned yet? And at this point, we'll give you some time for any comments or any questions you have. We'll try to take and answer as many of your questions as we can. So if you have any questions, I think, Ms. King, you place them in the question and answer session, I think.
Yes, colleagues, please place your questions in the question and answer box, not the chat.
Question.
Okay, so you may go right ahead. Thank you.
So I see one question there so far. Does Barbados ban the use of antibiotics in livestock for growth promotion? And does Barbados allow the importation of livestock meat where antibiotics are used for growth promotion? That's a good question. There has been recently some regulation which has been passed, which gives the authorities in Barbados the legislative right to restrict the use of antibiotics in livestock for growth promotion. And does Barbados allow the importation of livestock meat where antibiotics? There are certain restrictions that exporters must meet in order for products to be imported into the country. And again, this new legislation housed under the veterinary services and the chief veterinary officer will have the authority to either regulate or restrict the importation of meat where it can be proven that there are antibiotic residues in that milk or eggs or whatever product it can be. So yes, the legislation will look at both these aspects of antimicrobial resistance. The next question was, were there any particular antibiotics singled out in terms of AMR? This goes for both humans and when you say singled out, I'm not too sure if we're thinking about any particular antibiotics. I'm not too sure. Okay, if you could possibly maybe amend the question a little bit. I'm not too sure exactly what you mean. And the next question, do topical antiseptics cause significant AMR? Dr. Gittens St, Hilaire, do you want to take that one?
Yeah, sure. I will take this one. In terms of topical antibiotics, topical antiseptics causing significant AMR, no, they don't cause, they're not a significant cause of antimicrobial resistance because you're using them usually for a very short time and they don't remain, and there's no indication for, using them over prolonged periods or anything like that. So usually they're not associated with significant AMR, even though we have, there's been a reduction in the production of like hand sanitizers, not the alcohol based, but like the hand wash that has in antibacterials and so forth. That's been stopped because, or reduced significantly, because that's been associated with antibiotic or antimicrobial resistance developing, but not the topical antiseptics. They shouldn't be causing significant AMR at all. Actually, they might even help to prevent AMR in some instances, but once you use them judiciously, they should not contribute to development of antimicrobial resistance. I can go on and answer the next question. What is the proper way to dispose of antibiotics? Really and truly, at the end of the day, you should not have any leftover antibiotics. You should have used the full course of antibiotics. However, if for some reason, maybe you were, there was a reason why you had leftover antibiotics, it's the best to take them back to the pharmacy. Do not throw them down the sink. Do not throw them in the garbage. Don't give them to somebody else. Don't give them to a family member. Just take them back to the pharmacy. Okay, next question. How did those persons who use antibiotics for a cold obtain the antibiotics? Are pharmacists being educated? So that these are preliminary results. We have not done any analysis as yet to see, if those persons who use the antibiotics for a cold, where they got them from, because that was kind of like one of the questions as well in the questionnaire. So we have not been able to, we haven't analyzed that. We haven't done the granular data analysis as yet. This is just the initial, very preliminary results that we shared with you. So we're not able to answer that question. The other question, are pharmacists being educated? I cannot make any assumptions as to whether they've been educated or not, but I'm sure they have, I mean, in terms of, I guess you mean in terms of just specifically in terms of antimicrobial resistance, I'm sure they would have been educated, but I'm not part of the pharmacy program, so I'm not really educated to provide a appropriate answer for that. I will probably putting my foot in my mouth, so. But I'll, it could an antibiotic use. Okay. And because these questions relate to humans, I will continue to answer. When we say antibiotics are used to treat colds, we mean chest colds, which can cause congestions or what we call a rattling cough. Amoxicillin is usually prescribed by doctors in this regard. Is that okay? So when we're not talking about the common cold. So when we talk about colds, we're talking about upper respiratory tract infection. So like you're sneezing and coughing and those types of things. So like a cold, not like what we call like a chest cold. When you talk about a chest cold that is rattling and you got wheezing, and the other rails and rhonchi, other terms, you have all those things going on your chest. That tends to be more associated with a chest cold, what we call a chest cold, colloquially in Barbados, or what might be considered as pneumonia in some instances. Pneumonia it can be viral in origin too, but it can also be bacterial. And it would be appropriate in some instances to be able to prescribe an antibiotic because of that. Usually that pneumonias are associated with bacteria. So it would be appropriate to prescribe something like amoxicillin or so forth. Of course, that would certainly depend on the organism causing it, but as I said, most of the time it is associated with bacteria. So in that instance, it would be fine.
Dr. Gittens St, I would like the question which I was unsure about. Were there any particular antibiotics singled out in terms of AMR? I don't know if we could allow the person to either retype or if the person would like to ask the question live, so we could get some clarity. No.
Is she referring to like medically important antibiotics, like for example the same amoxicillin and amoxicillin cationic acid that will be present on your rare list?
Well, yes, because certainly in our studies we found there are certain antibiotics that are preferred not only in Barbados or in the region. The amoxicillin clavulanate is one of the antibiotics that's used widely in the region. And that's used both, and amoxicillin clavulanate is used in animals and is used in people as well. So that's one of in terms of any antibiotics that we're singling out, have to be the ones that are used extensively both in humans and animals. So yes, there are some that are used only in animals, and there's some that are used only in humans. And then there are lists and categories of antibiotics, like critically important antibiotics, high priority critically important antibiotics that we tend to want to leave for you. Some we want to leave only for human use, and some we want to leave only for animal or plant use. So I don't know if that kind of explains the question you were asking.
Okay, the person who asked the question, but I see you have anonymous, but what you can do, you can probably put in the chat yes or no to let us know if Dr. St there or Mr. Elcock were able to help you in this regard. Okay, I've been checking the chat and I don't see, so I'm assuming that you helped there with that response.
I do see that in the chat. Someone has said the question has been answered, so hopefully.
Yes.
Okay, so that's just good.
Okay, so there is another question. What are your views on using antibiotics in young children as a last resort?
Dr. Gittens St, I'll leave that one for you.
No problem. There is nothing wrong with using antibiotics in children, because some of these infections would have resulted in the era where there were no antibiotics. It would have resulted in significant deaths of young children. So the use of antibiotics in young children is appropriate. It might not even have to be the last resort. It might be the resort that you have to go to antibiotic because there's nothing else that you can use. So yes, you can use antibiotics in young children. It is if the infection requires the use of antibiotics, then certainly they should be used. There are other points where you may not have to use an antibiotic. You can certainly, the physician will be the one to make that call in terms of the wait and see approach, or whether they are going to go and use the antibiotics right away. Because some infections just absolutely require
Dr.
an antibiotic. If
excuse
not,
me.
it can progress, and certainly.
You're dropping in and out, Dr. St. Hilaire.
Yes.
Okay.
Oh, sorry. Yeah,
So
I
could you
just had a little
repeat?
bit of unstable.
Okay.
Yeah, so okay, no problem. I was saying that antibiotics can certainly be used in young children. Even if it's not as a last resort, it might be the only resort. Because before antibiotics, a lot of children would have died from infections that were relatively mild, but because there were no antibiotics, they could not have been treated. So some infections you might have to do a wait and see approach, and that is based on the physician's view of things and of the particular infection. But certainly it is important to be able to use antibiotics in children as necessary, and of course use them judiciously. So I hope that answered your question.
Okay, we have another question. How does one prevent green mucus, whether coming from the head or chest, with the onset of a viral infection? I am thinking persons here are seeking medical advice, but please concentrate your questions to AMR. But Dr. St. Hilaire, if you want to go ahead and respond to this question.
Okay. Some viral infections might produce a variety of different colored secretions. So it may be green, it may be yellow, it may be clear. In terms of prevention of green mucus, I'm not sure if you're thinking that that is associated with a viral infection or infection getting worse. But certainly you can go from a viral infection to a bacterial infection, because viruses can actually pave the way for bacterial infections. And so you might even get a more severe infection. So it goes from very upper respiratory to lower respiratory. So it goes from your nose, etc., into your chest. And the mucus being produced might change in color based on the bacteria that is there. There's nothing really that you can do except, go back to your doctor, say it's gotten worse, and then see if there is a need for a prescription or some other intervention.
So colleagues, do we have any more questions? The floor is still open for your questions. Okay, it seems as though we have no more questions. Oh, yes? Oh, yes. There are two more questions, actually. We have the question, does genetics play a role in AMR, having a particular genetic disposition to diseases?
Okay, as it relates to genetics and not directly to developing a multi-drug resistant, to acquiring a multi-drug, sorry, to having a resistant organism. What genetics can play in is a role to a particular disease, which might increase your chances of becoming infected with the organism, and it might not necessarily result in a person having a multi-drug resistant infection. But there are some genetics or genetic predispositions to certain diseases that can increase, or some genetic predispositions that increase your risk of getting an infection with a particular organism, whether it develops resistance or not, or you have a genetic disposition for that organism developing resistance. There's no rule, as far as I'm aware, of genetics being associated with an organism developing resistance, more so of an organism being associated with a particular disease. So for example, if your immune system is not working well, you might have certain deficiencies, then it might predispose you to infection with a particular organism. But it doesn't mean that you might develop a multi-drug resistant infection or drug resistant infection. I hope that answers your question.
We have another question. How much indiscriminate prescriptions of antibiotics occurs, to your knowledge, in prescribing antibiotics before confirmatory lab results are available?
I personally do not have an idea of this. This is probably something we would have to investigate in terms of indiscriminate prescriptions occurring before you get a confirmatory lab result. Sometimes you don't always need a confirmatory lab result in every single one, but every single infection, because sometimes you can look at the clinical signs and say, yes, this person has this infection and this is the drug of choice for this infection. But in terms of indiscriminate prescriptions, I can't tell you, because I have not done any research in that area, so I can't tell you for sure. But it would be interesting to find out.
Well, also to the person who asked the question, Mr. Greenwich, don't forget in Dr. Gittens' presentation, we said globally about 50% of antibiotics are prescribed inappropriately globally. So that can be a guide for what maybe for the question that you're answering.
Mr. Elcock, I'll leave the next question for you.
Okay, so the next question is, do you think AMR is contributing to the recent surge in bird flu? No, I would have to say no. Bird flu is caused by a virus, and AMR, what we're talking about is really is AMR, which is a bacteria. So even though they could be resistance and viral agents as well, I don't think that is contributing to the recent surge in bird flu. I don't know even know if I want to hazard a guess as to what is contributing to the recent surge in bird flu. Before we know migratory birds were the cause of spreading into the last bird flu outbreak. There was a great role that migratory birds played in spreading bird flu around the world. You know, we can have the nicest borders and border controls and regulations, but wild migratory birds are not concerned with borders. So they cross from country to country and continent to continent, and with them goes their diseases and their conditions as well. And bird flu was certainly carried all across the world by wild migratory birds. I don't think that there's a role AMR is playing in the recent surge of bird flu currently.
So colleagues, any more questions? I think then if there are no more questions, we can close our Q&A now.
Good.
So
I just want to thank you all for your questions and your rapt attention and for attending the session today. And I hope we have made the case for reason why we should be concerned, and that you will pass the information on to your friends and your colleagues so that we can try to stem the tide of antimicrobial resistance in this country. Thank you very much.
okay, thank you, Mr. Elcock.
Thank
So
you,
sorry. So there we have it, a very comprehensive discussion on the growing threat of AMR and its wide-reaching implications. We looked at what AMR is, emphasizing how the overuse and misuse of antimicrobials in healthcare, agriculture, and everyday life can contribute to the rise of drug-resistant infections. A key focus was on AMR and human health, detailing how resistant infections lead to longer illnesses, increased medical costs, and higher mortality rates. The economic burden of AMR was also examined, highlighting its impact on healthcare systems, productivity, and the financial strain on economies. Another critical aspect was explaining how resistant bacteria in agriculture and livestock production threaten food safety and reduce the effectiveness of treatments for both animals and humans. The conversation also tied AMR to sustainability goals and environmental concerns, discussing how antimicrobial residues in soil and animals can spread resistance and impact our ecosystems. This session concluded with a call to action. Colleagues, AMR is our business. Let's play our part. And as we come to the close of today's webinar, I want to extend a heartfelt thank you to our presenters, Dr. Marquita Gittens St and Mr. David Elcock, who have been so keen on sharing their expertise and insights on this critical issue. Your knowledge and dedication to addressing antimicrobial resistance have truly enriched these discussions. And to all our attendees, thank you for being here, for engaging with the content, asking important questions, and contributing thoughtful comments. Your participation is what makes conversations such as these meaningful and impactful. Before you go, we kindly ask that you take a few moments to complete the attendees questionnaire. Your feedback is very valuable to us here at the Learning and Development Directorate. It helps us improve future sessions. and ensure that we continue to bring valuable discussions to you. Thank you once again, and we do look forward to continuing vital conversations such as these. Colleagues, stay safe, take care, and continue to have a wonderful day, and wishing you all a great weekend as well.